What's good, YouTube? You're back on S Motorsports. Today, we're taking a tour of the Minnesota State University Mankato's Engineering Technology Facility. All right, guys, like I said, today we're at Minnesota State University, Mankato. If you didn't see the last video where I had the Camaro on the dyno, you should probably go check it out because I'm not gonna tell you what it made. It was really, really good, so you should go check out that video. But in this one, we wanted to take a tour of basically my old college, but basically they have updated a lot. There's a lot more facilities. A lot going on. Actually, the program is kind of getting revamped a little bit as well. So there's a lot new going on here. And I wanted to show you guys kind of what the program's about, as well as kind of all the cool stuff you get to do here. Yep. So really, we're gonna start there. All right, we got Paul here. Paul is gonna tell us what he does here at Minnesota State University and tell us more about the program and what it all entails.
So we're here in Mankato, Minnesota. We have an automotive engineering program here at the university. And my job on campus right now is research-based versus teaching. I used to do some teaching. We're here in the automotive lab. We have an automotive engineering program, and this is just our auto lab where students come in their first year and learn how to use some basic automotive tools. We are not service, we are engineering design type of thing, where some people get confused on that. We're trying to get students able to go out into industry and do anything with a vehicle, whether it's performance aspect, putting performance parts on their custom cars, working for a company making performance parts, or working for an original equipment manufacturer, doing testing on new vehicles, developing new vehicles type of thing. Our students end up going all over the country, but they start here in this room where some students in high school don't have auto shop. So we have to show them how to use tire machines, just some basic engine stuff. One of the things we do is a complete engine teardown. Some kids in high school no longer take apart single-cylinder engines, so we make them take a motor completely apart to truly understand the weight of a connecting rod or a piston, so they can understand if they want to make a performance motor in the future, make those parts lighter, motor works better. So we're gonna give you a little tour here, show you some of the other rooms. And one of the capstone projects that we do here is this Formula car, or Formula SAE. And it really is a mini Indy car. It has aerodynamics, front and rear, paddle shift. It uses the motor out of a modern sport bike motorcycle. This year, they're running a Yamaha R6, 600cc engine. Everything on this car is student designed and built. I mean, we buy the motor, the throttle body, but like even the intake is 3D printed. Someone on the team needs to learn how to weld to make the exhaust, to make the A-arms. We don't teach welding here as become a welder in a career. We teach welding for the aspect of you need to understand how welding affects the metal, or should you bolt something together? Should you rivet something together? Because all those different fastening techniques are different ways of holding something together. When should you use one? When should you not use one? It's a very well-rounded program. We are a very hands-on program. About 10 students per year take this. We build a new car every year. This is last year's car. This year's car is still a pile of tubing and a dream because they're building it on the computer, trying to figure out if they want to change tire size. They want to change how the pedals are mounted. They want to put bigger brakes on the car. They're making all those decisions right now, model it three-dimensionally on the computer, try to determine more aerodynamics, less aerodynamics, because of course the more you put on, the more drag the car gets at speed, but cornering speed is what this car is really made for. Acceleration on these cars is very, very quick. The car is just over 400 pounds, about 70 horsepower. They make us breathe through a restrictor.
That's what
19 millimeters, I believe is the restrictor. It's 19 millimeters.
That's crazy that you're still get
Which-
70 horsepower out of it.
which is right here. You can see where it necks down. That is the restrictor right
Yeah.
here, you know, for size reference.
Yeah.
So,
it is
and that's
kinda
also
crazy.
3D printed. So,
okay.
which the next lab that we'll go into has flow benches for measuring airflow to try and build the best approach and departure angles of that restrictor. We'll show you another lab where the 3D printer can actually create the intake manifold that this car is using. When we built a Formula car years ago, we could only build intake runners based on aluminum tubing sizing. You can only buy aluminum tubing in inch and a quarter, 3-inch radius, 6-inch radius. You were limited on what materials you could buy. Where now,
And shape.
well, correct. And now, if they can dream it,
Yeah.
draw it on the computer, it'll 3D print it. So we will make several different intake manifolds, flow them on the flow bench, flow them on the run them on the dyno. And yes, we actually run these on the car. It's not just for looks or something. It's stiff enough. 3D printing has come a long ways. There's even 3D printed aerodynamic wings and stuff that we have ran. So this one happens to be a carbon fiber wing. And yes, we're using the string technique for trying to determine some of the airflow.
Ford versus Ferrari.
Yeah, Ford versus Ferrari technique, yep. And it's not on this car, but these little aluminum dots, we actually had active aero on this car. So based its speed, the wing would adjust itself. Right now it's solid. So more downforce when you're going slow, faster speeds, it opens up for less drag. These are student designed and built cars. So they actually try to keep the cars like under 60 miles an hour because it is a parking lot. It is a cone race, very tight corners. There's acceleration, autocross, skid pad endurance, a series of racing events. We've done other vehicle projects. Years ago, we actually used to do a clean snowmobile challenge, which is a snowmobile up there in the rafters that we just kind of stuck up there.
Oh, yeah.
But the idea of that was take an existing chassis, existing snowmobile, and make it cleaner and quieter. Because that original project, they wanted to run snowmobiles in national parks, but they wanted them to be quieter and cleaner. So if you look closely, you can see we added a catalytic converter to that vehicle. So the problem with that competition is there's not a whole lot of universities up in the snowy climate, and they've actually discontinued the snowmobile competition entirely, I believe. I can show you some of the other equipment we have here.
Yep.
So, you know, this is just a typical iron block 5.3. Nothing fancy on this engine at all.
But everyone's favorite.
Everyone's favorite.
Except the internet. The internet hates them.
Yep. But, you know, we just obviously use this as a teaching tool type of thing. And if you look at the motor, you can see, you know, we have, you know, exhaust temperatures, oxygen sensors, things like that. And that is the old way of kind of engine tuning, is exhaust temperatures, reading spark plugs, oxygen sensor rich and lean. But original equipment manufacturers and engine development stuff, they use what's called in-cylinder pressure. So there is actually a pressure sensor inside the combustion chamber. And, you know, from cranking compression, you have maybe 200 PSI of cranking compression on a performance motor. But once that spark plug fires the fuel, you're 2,000 PSI within a couple degrees of crank rotation, right? Well, is it 2,000? Is it 1,800? Is it 2,400? Change the timing, those numbers change dramatically. And that's in-cylinder pressure. And we have that on this motor to show students that's what original equipment manufacturers are using now for tuning.
That's pretty cool.
This sensor on the front, this is actually called an encoder, which is basically a really sophisticated crank sensor. Yep. Your crank sensor can't read RPM fast enough, right? If whatever number of teeth you have on your crank sensor, keep the math simple. If you had 36 teeth, 360 degrees, you truly only get a signal every 10 degrees.
Yeah.
Okay?
Versus like encoders, that's what they use on electric motors.
Yes,
you know,
and that encoder is actually 720 degrees for one rotation. So it's actually every half a degree, it knows exactly where that motor is. And how it does it, there's actually like 5 little sensors inside there for reading, because if you put the teeth too close together, you don't get a good signal. So it's a sophisticated piece of equipment that we have here that the students learn on, because that's what they will see if they go into industry, is in-cylinder pressure. And that is a true way to look at timing, knock, instead of a knock sensor, that's after the fact type of thing. So you can actually see spikes in the combustion chamber and when they're happening. Yeah.
Where is that, or where is that integration in the combustion chamber? I'm curious, because I am not familiar with that, and that sounds really cool.
It is actually this little wire going in right here.
Oh.
So the problem with in-cylinder pressure is obviously you have to drill a hole into the combustion chamber, which is hard to find places in modern engines that don't go through the coolant jacket, or you have to make something for that to happen. And then that comes back to this box here to actually interpret that little power pulse signal into here, and then that goes into the computer.
So is that just literally outputting like a 5-volt signal?
I have no idea.
Okay. I don't know.
Edit that out.
Yeah. We gotta leave it in now.
Yeah. No, it's just it's not part of a.
Yeah. That's really cool though. Like I didn't know that.
I know exactly how that encoder works because I have one on my big dyno. But
very cool.
But yeah, so that's definitely something that we have added to this program. So I mean, yeah, the motor is nothing fancy. You know, we don't even run this thing high RPM. It's just a tool just to show students how this stuff works.
Yeah. It's a learning tool. But it's a fun learning tool.
Correct. And yes, we have like HP tuners again so that we can disable a coil or something just to see what that does to the engine when it's running. Again, we don't teach tuning as then go into that career. We just show you that as another tool that is used to adjust things and like again, I just keep thinking like, you know, the program as a whole and what it's taught me is it gives you a good overview of how to do things and how to work with different systems and stuff, but you're not necessarily not every graduate is truly going to work with an engine.
Yeah.
You know.
Yeah, but it's like you're getting skills that you can use in the industry, but it's not necessarily we're teaching you to do this one specific job because it is a general, you know, engineering program. That, you know, you're learning a lot of these skills which, you know, hopefully you can take to maybe some of the fun equipment manufacturers and stuff like that. All right, so we're now in a different room, right across the hall, actually. What room is this? I mean, I remember it, but I don't remember.
So this is just one of our high-performance engine rooms. We have a engine dyno in here.
More dynos.
This is the same motor that is run in the Formula car over there. And the green thing is the dyno that puts the load on it. And lots of sensors, figuring out pressures and stuff, whatever the motor is doing, so we can try and get the most out of the engine.
Yeah, I mean, obviously with the Formula car and that restriction, you know, you're trying to make that as good as you can, get the most power, most everything.
And how we determine how much airflow we get through here, we have a couple different flow benches. And this flow bench is the easiest to kind of show what's going on, is whether it's a cylinder head or even an air filter. We've done air filter testing where simply putting something on for measuring air flow, air out, and this will give us the amount of restriction that the air is, you know, versus being completely open. And then you can determine how much airflow that actually is by just using something simple as a water manometer. We have electronic versions of this too. It's just this one is a little easier for people to grasp. The you know, this measures sucking through a straw, a big straw versus a little straw. That's really all a flow bench is doing. And then whatever size straw you're testing.
I remember when I was in school, like we did, I think cylinder head porting actually. And like we got to test how that changed and stuff, and that was a lot of fun. And I mean, it's fun, but yet you're getting expertise or, you know, experience on equipment like this, how to use it, what it's doing, and also the principles behind it. But you get to do it on something fun, you know.
Show you our 3D printing lab next.
Oh my God, what is this?
These are some of our vehicle simulation computers.
You get to play video games?
We get to play video games here.
I didn't have this. This is a ripoff.
No, this is very specific. So that Formula car, it truly takes a professional driver to drive that car competitively. Anybody can drive it, but trying to drive the car competitively, we do some driver training on these. students learning the paddle shift, because we can put everything into this computer exactly what it is on that car. We can measure the shocks, we have the dyno graphs, we can enter all that stuff into here. And this is actually very similar software to what original equipment manufacturers have. Ford, Chevy, Toyota run the same type of program that we do that runs this. So, and I know very little about it because it's not part of my thing.
But it's still cool.
It is. It is. Cool. I mean, the computer can simulate the autonomous driving. You can simulate ABS brakes. You can simulate anything you wanted to test in the vehicle can go into the computer and it can be simulated in here, so you can see how the vehicle would act and respond.
Yeah, that's pretty.
Yeah,
that's pretty awesome.
It is. You know, lots of 3D printing. It's in pretty much everything now. Companies use it everywhere. We have a giant 3D printer here where we can literally print something 3 foot by 3 foot by 3 foot.
That is.
So it's
very large.
It is very large. That is the you know, here we have it printed the rocket up there, and then the dude sitting there.
That's one print.
That's one print. Yeah, that is one print. And it can do obviously way larger than that too.
Yeah, but is it 3 foot high as well?
Yeah, 3 foot high. Yes.
Wow, that is a very large.
In a single.
Single print.
Yeah, single print. Yeah, because some other printers are set up with a movable bed, type of thing, where you could do theoretically almost infinite. Well, this one is just a 3 foot by 3 foot by 3 foot.
So I mean, question: do you guys print body panels too?
We could, like the wings on the Formula car.
Yeah, okay.
Or if we just want to print more of a mold and then lay a fiberglass on that mold.
Oh, yeah.
That works very well, because when we did it, it was styrofoam, shave it, it was a mess. It took a very long time. And if you don't have an airplane wing in a perfect shape, it does not work at all.
Yeah,
and that is something that we have now improved. Yep, that this can make very specific shapes. An airplane wing upside down to create downforce.
Pretty awesome. What are we printing here? It looks like a dragon. It probably is a dragon.
No comment.
No comment.
One thing on the manufacturing side here that the students do, they 3D print their own little robots.
Oh, like for a class, you mean?
Yep. This is actually for a class. We'll give them the little electronic parts. They draw it, 3D print it, and make it before we let you play with a real robot.
Yeah.
We need to make sure that you can operate one of these and then control it with the computer. More on the manufacturing side than our automotive engineering program.
Yeah. But so here's a question: when I did it, it was a manufacturing minor. Is
Correct.
that still the case in the new
Correct.
engineering?
Yep. So
engineering program?
we are automotive engineering, and manufacturing engineering has also changed a little bit over the years since we went through the program.
Is it still a minor?
Yes, you still get a minor.
Okay.
Yep.
Cool.
Yep.
Well, you guys got all the fun stuff now.
So this is our engineering projects lab. So if a teacher gave you an assignment like build me a better mousetrap, this is the lab students would come in to do it. And some students have never used a drill press, much less a hand tool, versus a lathe or a mill or a CNC equipment. And this is where they get that hands-on experience to truly understand what it takes to fabricate something. And they get it in here. Again, we're not trying to make machinists in here. We just need students to know what can you make on a hand mill versus what can you make on a CNC mill.
Yeah. And I will say, as being an engineer for 20 years or whatever, I mean, that type of knowledge you need to have, because you're the one as an engineer directing people, your machinists, and you're coming up with, as an engineer, designs, tool designs, whatever it is, and you can't be unknowledgeable about, hey, I'm going to do this, when actually, that isn't manufacturable. And
Correct.
That's kind of
not manufacturable.
That's the principles that you're teaching here of what different pieces of equipment can do.
So we have basically, like people familiar with a plasma table. This is actually a laser table for cutting out parts. But a new piece of equipment that we truly have that you want to get blown away with. And this here is our new laser welder. We're talking about new technology and stuff that's out there and trying to get our students familiar with everything that's out there. This is our laser welder, and it turns even novices into beautiful welders.
Oh,
this is a first time someone used it.
That's crazy.
It is amazing.
And that is pretty thin metal too.
Yep. I mean, this is literally people.
Wow.
That's stainless. This is mild steel.
I mean, I had we did like some sort of welding when I was here, and I was horrible at it, and I'm still a horrible welder. But
and this is
pretty cool.
This is literally people's samples the first time they're using the equipment, and this is laser welding.
Yeah, and that's pretty thin metal. You can see.
Yep.
That's pretty neat. Yeah.
But this enclosure there's a factor of safety different in this type of laser welding than traditional welding. There's actually very little heat in this. You can pick up the sample almost when you're done welding it. But yeah,
we made it to the other building. So what is this building called?
So this is our Minnesota Center for Auto Research. And traditionally this building was put together to assist in the automotive engineering department in their research projects. So we did a lot of ethanol testing when we first put this building together. We do emissions testing on vehicle, basically tailpipe emissions. Not the most exciting aspect of automotive engineering, but it is something that is prevalent in anything. If you want to make and sell something in the United States, motorcycle, ATV, car, truck, boat, large diesel engine, they all have emissions requirements that they have to.
And that's that dyno there?
Yep, so we can go over there, yep. This was local Minnesota power sports company gave us a vehicle. The first iteration, we actually converted this vehicle, made it run on hydrogen. Right now it is converted back to stock, so we can use it more for student projects in the future, but at the time it was converted to run on hydrogen. And it is on a dyno, very similar to the Mustang dyno across the lab, across the campus. But this is an AC motoring dyno, which is a level even more sophisticated than the eddy current we have over at the Mustang dyno. This is an AC motor, literally just a large electric motor that is coupled to the rolls. You have to have this level of sophistication for doing emissions testing. All the regulations are just a little bit tighter on what proper load of the vehicle is.
I was gonna say, is it due to the control of the rollers, basically?
That basically, if you want to do emissions testing, and again, Polaris, Arctic Cat, Ford, Chevy, Dodge, everybody is running an AC motoring dyno and uses a road speed fan. So that fan is going 20 miles an hour when the vehicle's going 20 miles an hour. So you could actually test ram air effect with this one, which is not something you see in others, but big black cabinet here is our emissions analyzers. Hydrocarbon, NOx, CO, CO2, basically measuring what comes out the tailpipe on your vehicle is what this cabinet is. And
I mean, is this basically more or less what OEM manufacturers would use?
Yep. So if you want to step this way for a second. So if you've ever purchased a new car, you see one of these window stickers for city and highway fuel economy. Okay? City and highway fuel economy. Well, how do they get these mile per gallon numbers?
Yep.
We actually can do that here. And this is city and highway. 10, 20, 30 miles an hour. It's almost like a video game where we have to drive the vehicle, accelerate, come to a stop, accelerate, come to a stop in a standard test that everybody has used since the late 1970s.
Yeah, I remember doing that test on the Prius.
On your senior project, yep. And that's what this lab was built for, was a better way to do it than the old lab that we were in.
Yeah, I mean, this is a lot more advanced than what we had at the time, which is pretty cool.
Yep.
I mean, I feel like that really speaks to, I guess, the level of equipment that you guys have now. If you're getting OEM, power sports manufacturers, even if it's just power sports, you guys are almost like OEM type level testing, or you are basically.
We're trying to give the students that experience, so when they go into those companies, they can already do it from a start. Those companies don't have to spend 6 months training someone on how to measure exhaust gases.
Yeah, no, that's really cool.
Or how to do range testing on an electric vehicle. We can do the same thing. Instead of measuring fuel economy on a car, we can also measure like electric vehicle range. type of thing.
And that on the same dyno?
Yep, same.
Oh, okay, that's cool.
Yep.
I didn't know that.
And it's what's interesting, it's actually the same drive test. Actually the same drive test that will be driven over and over and over again until you deplete that 400-mile battery
Really?
down to zero. Yep.
Okay.
There's some other variations in it, but yes,
I did not know that.
Yep.
That's how
So
they...
it's not, they don't just run 60 miles an hour and then just wait 400 miles. No, they have to do a drive cycle simulating traffic in a big city, start and stop.
That's interesting.
What's interesting is the start-stop technology is because of all these stops. That is literally where your start-stop technology came in, is everyone has to do this trace.
Yep.
And they realize that the vehicle actually sits idle for like 7% of the time.
Yeah.
Well, if the motor was off, it saves fuel.
Yeah. All right, guys, so that was a quick tour of the facilities. A lot of new stuff here than when I went to school, but hopefully that's a good overview of kind of what this program offers now and all the different new stuff. Obviously, if you want to learn more, I'll put a link in the description to the specific automotive engineering site page where you can hopefully learn some more. If you have any questions, feel free to reach out to me. Paul, thanks for giving us the tour and stuff, and letting me come use the dyno.
No problem. Glad you didn't break anything.
Yeah, me too. All right, guys. Thanks. Till next time. Peace.